Hello everyone, my name is Mike Haywood and I'd like to welcome you to this presentation today. I'm joined by my colleague Mark Waterman and we'll be presenting the latest addition to the product range, the SelectiveRIDER. Here's a brief outline of what we'll be presenting. Firstly, I'll give a little background into the driving forces behind the development of the SelectiveRIDER and some of the processes we went through during that development. Secondly, we'll move on to a detailed overview of the product with key features and benefits of using the SelectiveRIDER, followed by a guided tour of the SelectiveRIDER environment in M.O.L.E map, which Mark will present, and then we'll finish up with a question and answer session so that you can ask any specific questions that you may have. We'll be muting everyone's microphones during the presentations, but feel free to raise your hand by asking questions in the chat box. The call out logo on the GTM or GoToMeeting app. So, if you're ready, let's get started. ECD, as the market leader in thermal process control, constantly monitors trends in the electronics manufacturing industry. Intelligence predicts a significant rise in the adoption of selective soldering as a process over the next few years. User requests for selective soldering solutions have dramatically increased of late. This is in alignment with the intelligence mentioned above. Our customers and partners requested a simple instrument that will measure the selective process collectively. Unlike reflow and wave soldering, there appears to be no one-size-fits-all solution, but the need certainly exists. These are the main drivers behind SelectiveRIDER. The SuperM.O.L.E Gold 2 is at the heart of everything we do, and it's the brain inside ECD's machine soldering process control platform. From initial product setup to measuring ongoing machine conditions, the SuperM.O.L.E Gold 2 is a single instrument that gives you full control. Machine parameters are measured and collected using high integrity, non-variable pallet systems. WaveRider collects preheat and wave dynamic information in wave soldering machines. OvenRider and reflow validator do the same job for reflow ovens, presenting thermal and conveyor data in a very easy to understand format. And now, with the addition of SelectiveRIDER, we have a simple to use tool that measures all the important aspects of the selective soldering process. Full setup and control of wave, reflow, and now selective machines with the SuperM.O.L.E Gold 2 profiling platform. One instrument, full control. SelectiveRIDER is the result of extensive customer research and global field trials concerning the measurement of the selective soldering process. The core of the SelectiveRIDER is the world-famous SuperM.O.L.E Gold thermal profiler. SelectiveRIDER can be used on all types of selective soldering machines, from the simplest standalone machines to the most complex inline high volume systems. It is fully self-contained and above all simple to use. Data interpretation, presentation and storage is achieved by using ECD M.O.L.E map software, globally accepted as the industry standard. The SelectiveRIDER pallet consists of a thermal barrier to protect the SMG2 throughout the process. The barrier contains an ejector to help with removing the M.O.L.E and a battery used for powering some of the sensors. The barrier is held closed by the latch. There is an over temperature warning label to ensure the pallet has been cooled sufficiently between cycles. The dynamic sensor collects the wave dynamic and thermal fingerprint of the machine. It can be easily removed to exchange for a different sensor or to replace if damaged. The mini fluxometer V gauge is accessed through the hinged cover. It too can be easily removed for cleaning and maintenance. SelectiveRIDER uses 3 basic sensor arrays to collect the relevant machine data. The dynamic sensor contains 2 thermocouples, one used for measuring the topside thermal parameters, the other for the solder temperature. The XY sensor, in the form of a cross, collects XY and nozzle size information. The process origin is used to trigger the measurement process, and the wave height ladder, which is stepped in 0.5 mm increments, collects wave height information. The mini fluxometer V gauge is used for measuring various aspects of flux deposition. The SelectiveRIDER pallet has fixed dimensions of 300 by 200 millimeters. That's 11.8 by 7.9 inches. It is designed to fit into the smallest of machines and can easily be placed in a carrier for machines with larger transport systems. The conveyor edge is machined to have a clearance of 10 millimeters, which is 0.4 inches, with 3 millimeters or 0.12 inch thickness. This allows transport in all conveyor systems. The pallet is very lightweight at only 1.72 kilos, which is around 2 pounds, and has an overall thickness of just 35.4 millimeters, which is 1.4 inches, which allows transport through the lowest of clearances. The pallet has fiducial marks to allow for machine vision correction. The same is true on the dynamic sensor and the V gauge. Correction is therefore possible at a local level. SelectiveRIDER measures the critical parameters identified during extensive focus group surveys. In terms of thermal measurements, maximum preheat temperature, solder temperature at the tip of the solder wave, the delta T at the point of soldering, and the preheat slopes are all recorded. Dynamically, the positional accuracy of the solder nozzle in both X and Y, and the solder wave height, the Z-axis, are measured along with the wave fountain nozzle diameter. The wave contact dwell times are also recorded. This gives a complete picture of how the machine is performing. We'll look at this in more detail in a few minutes when we look at the M.O.L.E map software. It's important that the selective machine is programmed using a specific sequence of events. This ensures that data uploaded to M.O.L.E map software is in the correct order for the software to interpret and present the information. Let's take a quick look at this sequence. The process origin is the starting point or datum of our measurements. From the process origin, we move to the preheat sensor, which measures the board temperature at the point of solder and calculates the delta T from the maximum preheat reading taken during the preheat stage. Following the preheat sensor, we move to the fountain temperature. This is an exposed thermocouple that reads the temperature of the surface of the solder fountain. Next, we move to the XY sensor, which is used to measure the dimensional offset from the center point. It also measures the fountain or nozzle diameter to ensure that the correct one is fitted to the machine. The Z height ladder is stepped in 0.5 mm increments and is used to measure the height of the solder fountain. SelectiveRIDER incorporates a patented mini fluxometer coupon. We call it the V-gauge. It can be used to indicate the XY accuracy of the dispense pattern, identify blockage in the spray head, confirm dots are being dispensed of the correct sizes, and illustrate if too much or not enough flux is being applied. The V-gauge uses a small fluxometer paper that is sprayed by the machine using a special dispense pattern. A good result will produce a pattern such as illustrated here. Defects will be highlighted by variations in this pattern. Here is a brief animation of the individual spray patterns on the V-gauge. The nozzle purge pattern is designed to ensure that the spray or jet nozzle is clear and dispenses a uniform pattern through all holes. Unprimed or blocked nozzles would result in an uneven pattern and potentially missing flux dots. This pattern should be run first. The dot control pattern is designed to help with dot size control. It should be programmed to dispense differing dot sizes and will highlight if there is any fluctuation in control between adjacent dots. The overspray pattern most resembles the function of the original fluxometer. It should be programmed so that 8 dots are dispensed in the center holes of the array. The result should be 8 clearly defined dots with little or no bleed into the surrounding holes. The Y-axis offset pattern should be programmed with 3 drag lines of flux deposition. The central row should result in all holes being well-defined circles. If the machine is correctly set up, the top and bottom row will only have a full circle at the left-hand side. All other dots will appear as ellipses. If the machine has an offset in the central row, it will appear as a series of ellipses, and only one of the 2 dots on the top and bottom rows will be fully complete. This will indicate the amount of the offset. The X-axis offset pattern works in the same way as the Y-axis pattern, with the offset being detected for the X-axis instead. It should be noted here that customers are free to develop their own measurement coupons for use inside the SelectiveRIDER pallet. This could, for example, be a sample cut from an actual product. SelectiveRIDER requires a machine program for each stage of the process. This can be one large program that includes all stages, or several smaller ones that treat each stage separately. Sensor coordinates are supplied in Gerber, Excel, and text formats. These can be imported into machine-specific program generators or used for manual programming. Once machine programs are generated, the operation of SelectiveRIDER follows a very simple series of steps as follows. Load the machine recipe and ensure the correct nozzles, etc. are installed into the machine. Allow it to stabilize. Insert the M.O.L.E into the SelectiveRIDER pallet. Press the on-off button to start the M.O.L.E. Press the record button to start the login cycle. Close and lock the barrier. Place the SelectiveRIDER pallet into the machine and start the soldering cycle. Once complete, unload the SelectiveRIDER from the machine. Unlock and open the thermal barrier. Press record to stop logging. Eject and remove the M.O.L.E. Connect the M.O.L.E to a PC and download the results into M.O.L.E map software. All measurements are presented in the summary sheet of M.O.L.E map. There's no need to look at a profile. All results are numerical and easy to read. There is a pictorial representation of the solder nozzle XY accuracy. All data runs are time and date stamped and stored in the M.O.L.E map database for future reference. Specification limits can be added for every parameter. Out of specification results will trigger a color change to highlight potential issues. The SelectiveRIDER environment of M.O.L.E map has full SPC functionality on all parameters. Here's a view of the summary sheet to highlight the out of specification color change and the visual interpretation of the solder nozzle placement relative to the required 0 point. Note how the graphic is off-center. SelectiveRIDER can be used throughout the entire life cycle of a selective soldering machine. It can be used at the specification stage to compare the performance of different machines against each other. When selection is complete, it can be used to capture key specifications prior to buy-off. Once delivered and installed, SelectiveRIDER can be used to compare machine factory settings are replicated and assist with factory acceptance. SelectiveRIDER ensures repeatability and control. It captures the fingerprint of a machine and can be used to reference back to this fingerprint after any major setup or maintenance has been undertaken. This always guarantees the machine is set back to its factory settings. Use the SelectiveRIDER for periodic checks at the beginning of daily production, at a shift change, when a new product is introduced, or when there is a quality issue downstream that points to the selective soldering machine. SelectiveRIDER is an extremely cost-effective addition to your process control regime. It ensures your machine is always operating within specification. This results in increased product quality and a reduction in machine downtime. SelectiveRIDER analysis offers an independent assessment of machine performance. A single SelectiveRIDER can be used to control many machines of different types. Maintenance and changeovers can be confirmed, which eliminates errors and increases uptime. M.O.L.E map traceability and reporting can be used to provide management and customers with evidence that your processes are within specification. SelectiveRIDER from ECD, the new standard in selective soldering process control. That concludes the presentation for now. What I'd like to do is to hand over to Mark, who's going to give us a live demo of the SelectiveRIDER M.O.L.E map environment. Okay, Mark, over to you.
Okay, thank you, Mike. So we're going to do a quick review of the map software. We've tried to make it as simple as possible so the demonstration won't have to go very long because we think we've done a pretty good job at it. For those of you that are familiar with our map software, we run in different environments depending on what type of product you're using or application you're trying to measure. And so we've added this new SelectiveRIDER environment to our map software in the newest release, version 3.21, which is available on the website right now for download. So we have activated our update. So if you have a version 3.18 or older version, you should get an ag that tells you to update to the latest. As Mike said, we have a summary tab. This summary is a one-page report. It gives you all the information needed from your SelectiveRIDER data run, including your thermal information, your maximum preheat. This is the topside foil peak temperature that was reached. before the solder fountain hits it. The delta T, that is the difference between the maximum preheat and the maximum temperature on the top coil, and then the actual fountain temperature. So these are our thermal measurements that we do from our XY sensor. And then we have our dynamic measurements for fountain size, accuracy, and dwell time. So we give you both X and Y offsets numerically as shown here, and also with a visual cue or target on the right. So you can very quickly assess if there's an offset, and then you can drill into a higher level of detail on the numerical side. We have height and diameter, and as stated, dwell time as well. You'll see this is highlighted red. That means that this value has violated our upper spec limit. So an operator can very quickly identify whether this machine is within spec or not by simply looking for red or blue values. If something is out of spec, it'll be underlined and in a color. That's driven by our spreadsheet. We have all of the various measurements that the SelectiveRIDER collects. We can also add our own custom measurements. We then look at those measurements over time, and we can put spec limits upper and lower around each one of those calculations and determine if a value is appropriate or not. We also have the ability to do our X-bar R charts and calculate CP and CPK. In this case, we can see that we have a individuals group, and we're using our upper and lower spec limits and calculating CP and CPK. This is for machine repeatability. You can do this on multiple machines. It gives you an opportunity to prove that your selective solder machine is in control and capable of the process. Just like with all the rest of our platforms, we can also do control charts so that upper and lower control limits are displayed for machine capability. People want to look at the profile and glean some meaningful information. Well, we've pulled all that meaningful information out for you and displayed it in the summary tab. You can still look at it on the profile. A lot of these dynamic measurements are based on timing, as Mike pointed out. Those timings are scripted and based in time. We ask you to hit the process origin first to start out the process, and then to try to hit these other points in order in a certain time. And that time that we've given you is based on a generic oven model. Oh, why can't I show that? That's on displayed on this profile. If your machine can't be programmed to that timing, you simply adjust these zones manually once. The software will remember that, and then the timing will be set from that point on. So you just repeat that same recipe over and over again, and it will provide you the repeated data so that you simply insert the M.O.L.E. It pre-programs itself to 1/10 of a second logging. It knows that it's in a rider product. You hit record, you run it through your selective process, you hit download, and then you look for red or blue numbers. So incredibly easy and intuitive to use. Okay. So with that, I will give it back to Mike.
Thank you, Mark. Hopefully, Mark and I have been able to introduce the SelectiveRIDER to you in some detail today. I'd just like to point you to our website, ECD.com, which contains a wealth of information not only about SelectiveRIDER, but our other products too. On the website, you'll find a full data sheet that gives detailed information on SelectiveRIDER, and you'll also be able to access the SelectiveRIDER Quick Reference Guide. This gives a step-by-step overview on how to set up and use the product. You can also download a fully functioning version of M.O.L.E map software that contains a number of sample files that you can use to get a better understanding of what you can expect from SelectiveRIDER. please visit ECD.com. Of course, we also have our global sales and support network that is ready to assist you with any additional questions you may have. Our team of specialists will be more than happy to arrange for a demonstration and provide price information. You can access the support network directly or send us an email at sales@ecd.com and we'll put you in touch with your local representative. ECD are pleased to announce that SelectiveRIDER is ready to ship as of the 17th of November 2020.